Welcome to day 14 notes, the last section of chapter 6, which is section 6.7, roots and zeros. First, to look at what we're going to do today. We're going to determine the number of real roots for a polynomial. This is a review. We've done this by looking at the graph before. We're going to find all zeros of a given function. That's something new. And then we're also going to write the equation for a polynomial given the zeros. This is a little new, a little review. First thing, we're going to determine the number of real roots for a polynomial. Just a little vocabulary. I think sometimes we get confused in math because there's so many different terms that are used. But if you're asked to find a zero, a root, a factor, an x-intercept, a solution, those are all referring to the same number. So a zero, root, factor, they're all referring to a zero. Okay, the fundamental theorem of algebra. This I'm sure you've been told before, but a polynomial of degree n has exactly n roots. They could be repeated roots, which means the same root more than once, or imaginary roots. So a polynomial of degree 4 will have 4 real roots. And then this is a little review. An even function has an even number of real roots, or real zeros. Remember that zeros cross the x-axis? The same for odd. So in example 1, our degree is 3. So this polynomial will have 3 roots. Because 3 is odd, it's going to have an odd number of real roots. So either 1 real root or 3 real roots. Look at an example. It says determine the number of real and imaginary roots for f of x equals x to the 4th subtract 16. First thing that you're going to want to do is put this in y equals and graph it. I already did that for you. When I did, this is what I got. We can notice that there's 2 real roots here because it crosses the x-axis twice. So real, there's 2 real roots. Okay, now looking at our degree, I have a degree of 4, so there's going to be 4 roots total. So if there's 2 real and I have 4 total, that means I have 2 imaginary roots. So that should be review. Here's one for you to try. If you would just take a minute, pause the video, tell me the number of real roots and the number of imaginary roots, please. Okay, the first thing that you should have done is put this in y equals and graphed it. When you do that, this is the graph that you get. Okay, number of real roots. I notice I only have 1 real root here. This point up here is not a root. That's a y-intercept, yes. It's not a root, though, because it crosses the y-axis, not the x-axis. So I have 1 real root, and that's this first point that I circled. Now, my degree is 5, so I have 5 roots. If I have 1 real root in total, I must have 4 imaginary roots. Okay, so that was just a little warm-up, a little review. Now we're actually going to find all of those zeros. We're going to find all of the roots. So here's your first example. It says find all zeros of the function. So the first thing that you're going to need to do is put this in y equals in your calculator and graph it. Okay, so I have this in y equals. I'm going to hit zoom 6 to graph it. If I notice, I have 2 real roots here. So my degree is 4, but I have 2 real roots. So what I'm going to do is I'm going to find what those roots are. So again, second, calc. I want to calculate the zeros. I'm going to look for that one on the right first. All right, my calculator goes a little slower than yours does. Okay, so I see right that point down there. Left bound is going to be above the axis. Sorry, that's my left bound. So my left bound is below, actually. Hit enter. Now if I go right, my point goes up, so that's my right bound. Hit enter. Hit enter one more time. Okay, there's my first zero. My first zero is 2, 0. Now I have to find that one all the way on the left. Just to save a little time, I'm going to tell you that that one is at -7, 0. So I have 2 real zeros at 2, 0 and -7, 0. So I'm going to write that down. 2 real at x equals 2 and x equals negative 7. Because my degree is 4, if I have 2 real roots, I must have 2 imaginary roots. So now I'm going to do synthetic division with my 2 roots. I'm going to start with x equals 2, so put 2 in the box. My coefficients then are 1x to the 4th, 7x to the 3rd, 0x squared, negative 8x, and negative 56. Bring down my 1. 1 multiplied by 2 is 2. 2 add 7 is 9. 2 multiplied by 9 is 18. I get an 18 there. 2 multiplied by 18 is 36. 36 add 8 is 28. 28 multiplied by 2 is 56. Add down. Now, is it a coincidence that I have a remainder of 0? No. Because x equals 2 is a root or a 0, I should always have a remainder of 0. So that looks good for me. Now I need to do synthetic division again, this time with negative 7. And I'm going to use this. So 1, 9, 18, 28. 1 multiplied by negative 7 is negative 7. This ends up being 2. So I'll multiply negative 7 multiplied by 2 is negative 14. Adding down, I get 4. This ends up being negative 28. Adding down, I get 0. Again, I got a remainder of 0. That's good. This is what I'm left with now. So I have x squared, add 2x, add 4. I know it's x squared because this is x to the 4th. Then here I had x to the 3rd. So down here it's x squared. So I'm going to set this equal to 0. I already have my 2 real zeros. So this quadratic here is going to give us 2 imaginary zeros. It's not factorable. So I'm going to do the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I get negative 2 plus or minus the square root. 2 squared is 4. 4 subtract 16 is negative 12 all over 2. Don't just start dividing everything by 2. I think that's really enticing here, but you can't do that. First, you got to simplify the square root. Root 12 is the square root of negative 4 and the square root of 3. So this becomes negative 2 plus or minus. The square root of negative 4 is 2i, and then I keep that root 3 all over 2. Now I can divide by 2. I'm going to divide this, this, and this by 2. So it ends up being negative 1 plus or minus 1i root 3. And then don't forget about those other 2 solutions you have, which were 2 and negative 7. And let's just go back and check. Again, I had x to the 4th. This gives me 4 solutions, 2 real, 2 imaginary. So just as a quick kind of summary of what we did, you want to look at the equation in y equals, find the real roots on the graph, and then do synthetic division. Here's one for you to do on your own. Put this into y equals and find the real roots on the graph. Then you're going to have to do synthetic division. After you've tried the problem, come back and we'll go over it together. Okay, so the first thing I did was graph this polynomial. Here's the graph that I got. So you'll notice we have 1 real root here. If you solve, you end up getting x equals 4 for that root. Because I have a degree of 3, if I have 1 real root, I'm going to have 2 imaginary roots. So first thing I'm going to do is do synthetic division with that 4. My coefficients are 1, negative 2, negative 5, and negative 12. 1 multiplied by 4 is 4, add down is 2. 2 multiplied by 4 is 8, add down I get 3, it's 12, and 0. I got a remainder of 0, so that's good. I'm left with x squared, add 2x, add 3. That's because if this was x to the 3rd, this one has to be x squared, 1 lower. Set it equal to 0. Because these are imaginary, and that because this does not factor, I'm going to use the quadratic formula. So I get the opposite of b plus or minus the square root, b squared minus 4ac all over 2a. I'm going to bring this up here. So this simplifies to be -2 plus or minus the square root of -8 all over 2. Again, don't just start dividing by 2. You have to simplify the radical first. So the square root of -8 is the square root of -4 and the square root of 2. So I get -2 plus or minus. The square root of -4 is 2i, because it's imaginary, root 2 over 2. Last step is to simplify this. This becomes -1 plus or minus 1i root 2. Please remember that root 2 just stays the way that it is. And then I'm going to do comma 4 because I have that other real root of 4 from the graph. So let's just do a double check. My degree is 3 and I got 3 solutions. Okay, quick trivia. Which country is ranked 3rd overall in gold medals for the Winter Olympics? By overall, I mean all the years that the Olympics have been around. Okay, last thing, we're going to write the equation for a polynomial given the zeros. So first thing is the complex conjugate theorem. If a plus bi is a 0 of a given function, then a minus bi is also a 0. So here's an example. If 3 plus 4i is a 0 of this polynomial, then 3 minus 4i is also a 0. What you should notice is the 3 stays the same. We only change the sign of the imaginary part. So it went from positive 4i to negative 4i. We're going to use this information to write the equation. So here's the example. It says, write a polynomial function of least degree with integral coefficients, the zeros of which include -1 and 2i. Okay, the complex conjugate theorem just told us that imaginary or complex zeros come in pairs. So if 2i is one 0, then -2i is another 0. So I have 3 zeros. So let's think back when we factored. If we got x minus 4, x plus 2 equals 0, we got 2 zeros of positive 4 and -2. Notice that these are opposite signs. -4, positive 4. Positive 2, -2. Because we're subtracting. So to start out this problem, I'm going to do x subtract -1. And then I have x subtract 2i and x subtract -2i. Simplifying, I get x plus 1, x minus 2i, and x plus 2i. This is equal to f of x. Unfortunately, you cannot leave your answer like this. We don't like to leave imaginary parts in our answer. So this is what I'm going to simplify first. I would always simplify the imaginary part so I can get rid of those i's. You guys know this. I like the box. If you just like to do the arcs, that's fine. So x subtract 2i, x add 2i. This becomes x squared, -2i x, positive 2i x, and -4i squared. What you should notice is positive 2i x cancels with -2i x. I get x squared subtract 4i squared. Remember that I squared is -1. So I end up with x squared plus 4. Don't forget, though, that you still have this x plus 1. So now over here, I have x plus 1, x squared plus 4. This is equal to f of x. Again, I'm going to do a box. If you just want to draw the arcs, that's fine. So I have x plus 1 and x squared plus 4. This becomes x to the third, x squared, 4x, and 4. So my last step, f of x is equal to x to the third, add x squared, add 4x, add 4. Okay, so I got a polynomial of degree 3, which should make sense since I have my 3 zeros of -1, 2i, and -2i. Okay, this is our last example. Pause the video, try this one on your own. Okay. So if we have -3i, positive 3i also has to be a 0. So I get x minus 4, x plus 3i, x minus 3i equals f of x. Next, you should have multiplied these two. I'm not going to show you the steps, but when you do, you get x squared add 9. And then you still have this x minus 4. Now I am going to do the box for this next part. So x minus 4, x squared add 9. This becomes x to the third, add 9x, subtract 4x squared, subtract 36. I didn't tell you this before, I don't think, but we generally go in descending order for exponents, so highest to lowest. Here that's going to be x to the third, subtract 4x squared, add 9x, subtract 36. This is my final answer. So I hope you did that one right. Just a quick look back at what we did today. You determined the number of real roots, you found all the zeros, and you wrote the equation given the zeros. So which country is ranked third overall? The Soviet Union. I thought that was kind of surprising. They've not competed in the Winter Olympics or in the Olympics at all since 1988. The first is Norway, and the second is the United States. Here is your entrance slip to class tomorrow. You will not be able to enter class without this problem being completed. Find all of the zeros. So remember, that means you're going to have to graph it, and you're going to have to do synthetic division with the real zeros. Again, we will check this as you come into class. Thank you.